Hello, everyone. Uh, Hopefully everyone can hear me. I'm Karen Adkins. I'm with the National Geospatial Program User Engagement Office. And this is the January 2024 USGS Hydrography Community Call. So we still have some folks joining, but we do have a great presentation today. We have Joe Trimboli from the Huntington U.S. Army Corps of Engineers District, and he is going to be presenting on the use of USGS data and services. Today we're going to start with a couple of announcements from Steve Achel. Steve, do you want me to share screen or will you do so?
Sure, actually, if you'd share the screen, that'd be just as well.
Okay.
Got more drama getting the slides up than the actual announcements.
Right.
That's all right. There you go. So just a couple of quick things. First off, we have regenerated all of the NHD staged products. So the HU4, the HU8, and the state products have all been reproduced and are out on the Amazon Web Cloud repository. Also available through the National Map Downloader. We're also regenerating the national version of the NHD staged product. That actually should be the same as what was done in August, but let's just have one clean set to close everything out there. And then did a little tidying up on the NHD Plus high-res cloud repository. So now there are two folders there under two folders with each of the VPU data sets. One is the archive version for VPUs for regions that have been superseded. Probably mostly you want to go looking in the current folder for the current data. That is the latest version, the last version of that data. And again, that's out on the NHD Plus cloud repository, available through the website. It will be available again through the National Map Downloader. There's a little bit of a wrinkle getting everything synchronized between the systems. That should be cleaned up here in a week or so. But just those two quick updates, and I guess back to you, Karen.
Great. Thank you, Steve. We're going to turn it over to Joe to share his screen. Joe, please feel free to share at any point. And for the audience, please feel free to ask questions. You can raise your hand or drop your question in the chat. So, Joe, I'll turn it over to you.
So I'll get started. So my name is Joe Trimboli. I work for the Huntington District Corps of Engineers in Huntington, West Virginia, and I'm a community planner with a geography degree here in the plan formulation section. And I want to thank the USGS for inviting me here. And just a little background. So we do our own outreach efforts too. And I met a USGS person at one of the Ohio floodplain management conferences, Cynthia Rachel, and she gave a great presentation, and I came right after her. So that's kind of how this started. This is my first time, for this webinar, and I'm very happy to be here. So I wanted to pick a good topic to interest to everybody and try to highlight not only USGS activities, but some of our own in the Corps. So I decided to show how we use USGS services in a program that I work in our district that I've started to call our micro GIS program. And this is just a little index of what we're going to go over today. We're going to look at StreamStats and the NHD. I thought that was neat that you led off talking about it. Going to look at the national map, our peak stream flows, how we use the gauges. And there's also some tools that, that are probably people are not as familiar with. And I'm going to talk a little bit about the facet programming. So the Corps, we do large scale and multi-scale watershed projects. So most of it starts with watersheds. A majority of our studies, if it doesn't start with a watershed, at some point we're looking at that type of data. So these are some examples of projects that we've done in our district for the Ohio River Basin, and the USGS data is a big part of that. But this is a result here from our micro GIS efforts. We have a program called Floodplain Management Services that pulls together aspects of our technical capabilities in the National Flood Insurance Program with FEMA. We assist private people in floodplain mapping and questions, in regards to the floodplain, pretty technical questions most times. And we partner with the local floodplain managers on this, who, we provide that services for free to them. And this example here on the left is one of these examples of where a local floodplain manager called us and was requesting additional information in a Zone A area that really doesn't have detailed mapping, but we were able to do some calculations and some small scale things in those on those requests. So this is how the Corps is structured. We do have a large scale GIS enterprise system, but we work basically under authorities where we either have an authority to do like floodplain and watershed assessments or not. But we're always working and cooperating with our technical partners and other federal agencies, the state, with this concept of technical support. And this on there on the right, on the yellow boxes at the bottom, it says Silver Jackets. That's one of our main programs in planning where we do that type of outreach. And that's how I met Rachel at the Ohio conference, because we were both there enjoying the presentations. So this is a diagram I created when doing one of the studies in one of the counties in West Virginia. And being a GIS professional, I really put an emphasis on data and how we can use and leverage data. And this graphic was intended to show like these pillars of our efforts, between agencies and the state, and what we do in those programs. And so we have this idea of data governance and data modeling that just transects and joins these programs together in strategic and both operational ways. And then I created examples of this data at the different scales there on the right. And we actively do these things, with our state and other agencies, and really worked hard to try to get this graphic to, present that in a very easy way and descriptive way. So I actually did that when I got back from being deployed to Afghanistan. I went over there as a Corps employee. We supported the NATO at that location. And that's kind of what gave me the idea about this, because while I was there, every federal agency we had was there too. So, it's not just, I know a lot of times we get in our little silos and think that, this is it. It's just the Corps, but that's not the case. And we also engage as multi-agencies overseas and, on the world stage too. And this is an example. It's a little bit older one, but we have some large scale water resource type of programs where we collaborate at very high levels with multiple agencies and do a lot of, HICRAS type coordination and mapping. And this was a good picture. It's a little old, but it was a good example of that. The SWIMS effort is is ongoing, and it's developing more every day. And we do basically large scale watershed modeling, and are working to share that with all our supporting and sister agencies and our states. But I'm here to talk about and put USGS tools in our perspective anyway. So back to our micro GIS effort, we specifically use a lot of USGS data. I mean, I'm not sure how we could do a lot of our programs without it, or at least it wouldn't be as easy. So some of the basic programs that came to mind when I was looking at this was the 3DEP program, because I know our USGS agency in West Virginia, where this was at, coordinated a lot of that type of data, the LIDAR data and the DEM data. And so that was a big national effort. And the other one that we use almost on a daily basis is the StreamStats program. And then when you start talking about StreamStats, you really include a lot of other efforts like, managing that data and making it available. And then it's just a huge amount. It amazes me. I'm a big fan of the USGS for sure. So on this micro GIS program, we've created a database where we take public requests, and this is that database. It's fairly new. We transitioned it from just a simple Microsoft Access database, and it worked very well. But with all the computer security and things progressing, we decided to migrate it to a more modern format in a web portal and backside database. And so we've integrated a lot of things into this. It also has the capability to copy seed files for each request that support that micro GIS concept and the idea of managing data and working with data on each request. It has geocoding built into it. We type in the address or coordinates from the individual we're working with, and it geocodes them or reverse geocodes them. But one of my favorite features of this tool, and it was a feature in the Microsoft Access Geo database too, but I'm able to put a pull down link here to referenced websites that are on the internet. And so this large list of basically titles of websites is blown up some so you can see it. There's a lot of USGS references on there. But one of the aspects of this tool is that list is created and maintained under this URL maps selection here. And I've got two examples there. One is USGS elevation data and USGS StreamStats. But what this feature lets us do is we can put a link to any website there. But the interesting and more technology, integration solution here is including the longitude and latitude from each request. So this is actually programmed in the database. So this is referencing the USGS query for elevation in feet. And these longitude and latitude are built into this database to convey the position from the request to that query provided by USGS. And a lot of this stuff looks real geeky and it's a little bit of code, but buddy, it works well, and this type of automation and integration into processes really saves time and it allows us to do our job and serve the public, in a very quick and responsive way. So what we're looking at on StreamStats most of the time is this StreamStats portion of the report that gives the discharges for different return frequencies. And most of the time we're looking for the 1% so that we can map an area in a zone A. The zone A does not have elevations associated with it, and they're needed. In the NFIP program, they're needed. So, and we support this, and we produce and calculate those BFEs using software that's provided and supported and developed by FEMA. So we definitely try to leverage and pay attention to our federal partners in these activities. And speaking of StreamStats, I'm not sure if everybody's aware of this portion of it, but there's also a interface that is just, they call it NSS report, that is kind of the same as the StreamStats portal, but it's not map based. So this is, basically the same type of query at that same location using this interface. But that whole, I'm not sure how wide and how, at least in the agency and how it's used, but they say down here at the bottom, powered by WIM. And I have to say that I think whatever that is, which I don't know, I think it's pretty powerful, and it gives, if you're a programmer, it probably gives you the capability to do a lot of custom and automation and automated things, kind of like what we're trying to do here with the integration of websites into our database. So this is a report from that database. It has the opportunity to include a single graphic in that database, and produce a standard report. And it really helps us in turning these requests around very quickly. And the database itself ends up being a repository of answered requests. So it can and hopefully would be used and could be used for reviewing the request and coming up with better solutions for these efforts and seeing what the problems are across a large area. So in the previous slide I showed that there's the ability to copy files. It creates a local file based on the ID for the request. And in that directory, we can copy seed files and other tools that assist us with these requests. So I like to use QGIS, which is open source freeware, as my GIS solution for doing these BFE requests. We have taught this to other floodplain managers. The process is not necessarily specific to GIS and or a specific application. It's more specific to GIS capabilities and functions. But this is a seed file. We pre-stage a lot of data layers over here and sources that we reference, and assisting and answering questions basically related to the floodplain in this situation. So one of the capabilities that this method provides is that in addition to supporting the NFIP, the typical types of questions that arise on the NFIP, a recent activities in floodplain management dictated that a lot of the states and or federal agencies are seeking a higher standard. So this is a request from Ohio where they was going to build a power station there at the red dot up on the top of the picture, but they needed the 500 year to be determined. So that's what this is a picture of. It's a very small project where we put a cross section. We measure the slope off the newest digital terrain. We calculate Manning's in values, and basically using the discharge, 500-year discharge is published in the StreamStats report. We're able to calculate a 500-year. And so right here at this cross section, you can see that there's a blue transparency that indicates that's the zone A. And these maps have different years of publishing, and sometimes the data hasn't been updated for a long time. But this picture shows the 500 year at this cross section in the red transparency. And FEMA accepts that as a minimum standard, for these efforts that we're doing. So thank you, USGS StreamStats. So what StreamStats does is it helps us leverage, this capability. I mean, this program would not exist without it. I've been using it. This program has been, we've been doing it since probably about 2006. We took some very analog old references to methods and processes and converted them to GIS. The database gradually followed, and we couldn't do it without the StreamStats. The multi-return period is a great thing to be able to do, especially with these more stringent standards. And the NFIP program and floodplain management is evolving. It just keeps getting better and better as far as identifying risk and trying to mitigate. But one of the things I would like to do there, that last bullet, is to navigate directly to the result using the coordinate capability I have in the database. I just think that would be so neat. So Drew and Karen, any help you can get, I'll take it. So next, I want to speak about the National Hydrology Dataset. I use that quite often. Matter of fact, so often that I created this layer out on a freeware site that lets you publish a map source. I inventoried all of the data directories there to extract one specific aspect of the National Hydrology Dataset. And so when I select a watershed in a location of interest, I can download basically the, I'm not sure what it's called in the data set. It's actually an elevation data set. And it's a pretty unique elevation data set because it's in centimeters. But man, boy, it downloads quick, and you're able to bring that into a GIS system and run basic tools on it pretty quickly. And this is kind of the steps we would use. This is that specific result. I could get it in there in minutes. I could narrow down to a project area pretty quickly and run some GIS applications on it. In this case, we identify all the streams and calculate a direction grid. And the reason why those are so important is because it lets you create a watershed, by selecting on a point anywhere. So if I have any point of interest, I can click on it and run a few GIS tools that shows that watershed. And it's really the same type of applications that happens in some of USGS portals. The same type of GIS methods are being used on, localized desktops and in desktop applications for using GIS. Excuse me. And so this is how we use that. I mean, we're planners. We get these RFIs that come in all the time. I'm a senior GIS person in our planning branch, so I answer a lot of questions, and most of the time the questions are either something measured geographically in GIS or something researched, on a large data set or tabular basis. But we couldn't do that without these tools from and data from USGS. And, if there's ever changes made to that layer that I'm using, I'll just have to recreate it. Or I think in this case, the USGS will probably have the tool. And I have to say that the national map is probably that tool. I use that a lot for downloading DEMs all over the country. Also, all of our studies are watershed based, so I download a lot of the watershed data, for reference in a project. And a lot of the GIS tools, they're great references on the portal, but I end up wanting to catalog and save the data to a project directory, just simply for archival purposes and or coming back to a project. So it's really nice to be able to download and find that data out here so readily available. Peak stream flow. So as the Corps of Engineers, we coordinate a lot with other agencies, and this is no exception on the stream gauges. I think my heater guys are knocking on the door, but I'm going to keep going. I apologize. We do this at a local level and a national level. We have programmers who write code that go out there and access this data on these web pages and pull it in for, applications that we're using. I'm sorry, I have heater guys here. I'm going to try to turn my heater on because they just replaced my furnace. But let me keep going. So we use the gauges at every level of things that we do at the Corps for hydrology and programming purposes. And the last thing I want to go over is there might not be a lot of people on here might not even know of this tool, but I found out about it in a EPA group I was participating in, and this is their website. It's called Water Resource Registry, and I generally work and participate in West Virginia and try to keep abreast of things that affect that particular state. West Virginia has a big presence in GIS from West Virginia University, and on this particular effort by EPA, they're partnering with states too. And our West Virginia DEP created models to be published on this EPA sponsored website. And it's pretty unique. Let's see if I don't know if I put here's the URL if you want to visit that site. It's a really amazing and one of the fewer sites I've seen that really leverages sharing data and creating a modeling effort, especially around water resources. So I knew that the West Virginia was interested in stream bank stabilization, and that particular group from the EPA was trying to create a stream bank stabilization model. So that's why I was interested in that. So what I found out during participation is that the FACET is a program that basically analyzes the DEM data and other different data types for the watersheds, and it is able to create cross sections and bank point shape files. So that was exciting to me. So I try to follow the development of that tool as close as I can. So this is a spreadsheet from this BFE effort that we do for developing the 1% annual chance return. And one of the things that we do there is we create a cross section for that site, and we look for the same bank points. What they call it over here, bank point slope breaks and threshold for bank identification. So this is how we're doing it now, just in a spreadsheet. Would like to automate that too. So in summary, this is how we've been using USGS data, and it's been very effective and appreciated. Micro GIS projects in support of flood risk management and BFE calculations using open source GIS, non-proprietary request database emphasizing USGS data sources and programs. That's all I have.
Thank you, Joe. That's really impressive. A lot of work. Please join us for our next meeting. That will be on February 27th, our February USGS Hydrography Community Call. And we are planning for Rebecca Ransom, a hydrologist with the USGS, to speak on the Tennessee Source Water Assessment Program tools. So we'll be sending that out soon. And thank you again, everyone. And thank you again, Joe. Really appreciate it. And have a great day, everybody.
Thanks, everyone. Have a good day.
Thank you.